Hi class, so this week we're starting on Inferential Statistics, Chapter 12. So Chapter 12 covers bivariate statistics and statistical inference. So hypothesis testing. So when you're dealing with inferential statistics, this is where you're starting to do your hypothesis testing, basically testing the relationship between two or more variables. Your statistical tests are used to find if there's a probability that the relationship between your variables is due to sampling error or to chance. So generally with the hypothesis, you have a null hypothesis, which basically means that there's no relationship between two variables. For example, there is no relationship between income and mental health. Then you can have the two-tailed hypothesis when there is a relationship. And when it comes to a two-tailed relationship, you're saying that there is a relationship between two variables. For example, there is a relationship between income and mental health. And then finally, you can have a one-tailed hypothesis, which means that there is a directional relationship, and so that the relationship between the two variables is going in a certain direction. So for example, the greater the income, the greater the mental health, or it can even be going in the opposite direction, right? It can be the lower the income, the greater the mental health. So a one-tail hypothesis is basically when you know that there is a certain direction in terms of the relationship between the two variables. Then the next important thing is the p-value. And the p-value, generally with the p-value, we use a p-value of a 0.05, which means that there is a 5% chance that the relationship found in the sample is a result of sample error. So a p-value of 0.05 means that there is a 95% chance that the relationship is not due to sample error, and it actually reflects the differences in the population. So you're saying that 95% of the times that this is not because of an error, but this is actually what it's reflecting. So the rejection level. So if your p-value is less than 0.05, we reject the null hypothesis and accept the alternative hypothesis. So basically, if you run a statistical test and you get a p-value of less than or equal to 0.05, that would mean that you have statistical significance and you are rejecting the null because the null is saying that there is no difference, when if your p-value is less than 0.05, that means that there is a difference. So that's why we would reject the null. So basically, the easiest way to remember this is 0.05 is kind of the standard in terms of research, especially in social work. We generally use a p-value of 0.05. So anytime we run, whether we run a correlation or a t-test or ANOVA, if our p-value comes back to be 0.05 or less, we have statistical significance, and that means that there is a difference between the relationship. Then you have to consider your errors. We have type 1 error and type 2 error. So with type 1 error, that generally happens when we reject the null hypothesis, but there's no relationship within the population. So this happens 5% of the time. If the rejection level is 0.05, this happens 5% of the time. And this basically means that we say that there is a relationship, but we're wrong. Type 2 error happens when we don't reject the null hypothesis, but the relationship actually exists in the population. And this could be due to maybe a sample error, or maybe we have a low rejection level. And this happens when we say that there's not a relationship, but we're actually wrong. Okay, so type 1 is when we say there is a relationship and we're wrong, and type 2 is when we say there isn't a relationship and we're wrong. All right, so moving on into correlation. So basically, linear correlation, or what we also call Pearson's R, basically with this correlation, we have to have two interval or ratio level data. So our variables have to be at the interval or ratio level. And we're looking for ranges. The correlation ranges from a +1 to a -1. So whenever we're looking to see if there is a relationship between two variables, we can do a correlation. But again, remember, the variables, both of the variables have to be at the interval or ratio level. So for example, is there a relationship between age and final exam score? So if you look at it, age, right? If you asked age on a survey and you just ask how old are you or what is your age, and they just give you a number, now you have a racial level data, right? You don't have categories, you don't have categories, so you have racial level data that way. Your final exam score, same way, it's an actual score. And so for example, someone may make an 80, someone may make a 65, someone makes a 90. Those are all racial level variables, right? So both age and exam score are racial level, so you can run a correlation and you can see if there is a difference between people's age and their final exam score. And in Excel, just an example of how you would do that on Excel, you would go to your data and do your data analysis and do correlation. Correlation, you're looking at the relationship between two variables, right? Only two variables. And so with positive correlation, the greater one variable, the greater the other. So if you run a correlation and you get a positive correlation, that means that the relationship is going in one direction. So as one increases, the other one also increases. So for example, if you have a positive correlation between education and income, that would mean that as education goes up, so does income. So education goes up, income goes up. That's a positive correlation. And you report it with an R. So your correlation here is an 86 or 0.86. Remember, correlation only runs from a +1 to a -1. All right. So with a negative or inverse correlation, the greater one variable, the less the other. So for example, life satisfaction and illness, if you look at the correlation, is a -0.74 or a -7, right? -0.7. So the negative basically tells you that there's a negative correlation. When you have no correlation, that means that there's no relationship between the variables. For example, IQ and shoe size. So let's say you ran a correlation on people's IQ and their shoe size, and you got an R of a 0.02. There's no correlation. And the reason you would know there's no correlation is because you got a 0.0, right? The thing with correlation, there's specific ranges in terms of when you know if there's no correlation. There is very low correlation to a moderate correlation to a high correlation. And I think we have that in the following slide. But when you do correlation, just simply know that correlation does not imply cause and effect. Just because two variables are correlated or shows that there is a relationship between the two, it's not saying that it's cause and effect. Okay. All right. With the scatter plot, it visually shows the relationship between the two variables. And this is what the positive correlation looks like. And then it goes, you see the direction it's going, and then this is the negative correlation. And this is what the no correlation looks like. So basically just a visual of what it looks like when you get either positive, negative, or no correlation between variables. All right, so here's that table I was telling you about. The R squared is your coefficient of determination. It is the amount of variance in one variable that is explained by the other. So correlation of self-esteem and GPA, for example, R equals 0.60, which is your actual correlation. Then R squared is 0.36. With your self-esteem is explaining 36% of the variance in GPA. Now here is a table I was telling you about. Here is how you can determine the size of your correlation. So if your correlation is 0.2, that means there's a slight to almost no correlation between the two variables. And if it's between 0.2 to 0.4, there is a low correlation or a very weak relationship. 0.4 to 0.70, that means there's a moderate correlation with substantial relationship. 0.7 to 0.9, there is a high correlation and there is a marked relationship. 0.9 to 1 is very high correlation, strong relationship. So whenever you run your correlation, use this table to determine where the relationship falls. Whether you have anything less than 0.0 or anything less than 0.2 would be that there's no correlation at all. All right, so if you're doing hypothesis testing, okay, so there's no relationship between age and attitudes. That's your null hypothesis, right? Your null hypothesis is always that there's no relationship between the variables. So your null hypothesis for this example is that there is no relationship between age and attitudes. And your alternative hypothesis is that there is a relationship between age and attitudes, okay? So looking at your correlation here, with Excel, it would look a lot different. This is an actual photo of SPSS. But looking at this, we're looking at age and attitudes and whether there's a correlation between the two. So R, that is our actual Pearson correlation. So it's right here, 0.48. Or p-value is down here, and our p-value is, let's see, let's see, 0.39. Okay, so right here where it says significance, that's your p-value. So our significance two-tailed is right here. So our correlation is 0.48 and our significance is 0.39. And remember, if our p-value is less than or equal to 0.05, then it would be significant. But since our p-value is greater than 0.05, that means that we don't have significance. It's not statistically significant, and so we are going to accept the null because that means that there is no relationship between age and attitudes. Okay, so if our p-value was 0.05 or less, then we would reject the null because we would say that yes, there is a relationship between age and attitudes. But because our p-value is 0.39, which is higher than 0.05, that means that it's not significant, and that means that there is no relationship between age and attitudes, and so we would accept the null hypothesis. And this is how we would report our results. So correlations are reported with your degrees of freedom, which is basically n minus 2, and n is your actual sample size. And we have that in your parentheses, and then significance level. So R, remember, that's your actual correlation. N is your sample size, and then P is your p-value. So you need all three pieces of that information. Your R, or your correlation, is actually the strength of the relationship. So depending on what you get for your correlation, whether it's a 0.2 or a 0.5 or a 0.7, that determines how strong a relationship is. So remember, the closer your correlation is to 1, the stronger the relationship. P-value is basically your significance level. N is your sample size, and then your R squared is your coefficient of determination. All right, so if you wanted to write up your correlation results, here's an example of age, income, depression level. Remember, your R is the correlation, the P is your p-value. So looking at this data here, we can say that there is a moderate negative correlation between income and level of depression. So this is level of depression, and so this is level of depression here, and this is income. So remember, correlation is the R. So we have a negative 0.6, all right? So that would mean that is a negative relationship. So that means as one of our variables go up, the other goes down. So if there is a negative correlation between income and level, that means income and level of depression, that means as income goes up, maybe that means the level of depression goes down, right? As the level of depression goes down, income goes up. And the way we know it's a moderate correlation is because, let's see, it's a 0.6. And so that's a moderate correlation, right? If we look at maybe here, 0.3, that will be lower than 0.6, so it would be more of a weaker correlation. And if you look down here, this is kind of how we write it up. So R is your correlation, 118 is your degrees of freedom, which is your sample minus 1. The 0.06 here, 68, that's your actual correlation, this right here. And then your p-value, which is down here, 0.001. So it is less than 0.05, so that means there is a statistical significance, and that would mean that there is a relationship or there is a correlation between income and level of depression. All right, and then again, here's another example of how you would write something up. So a Pearson product moment correlation coefficient was computed to assess the relationship between income and level of depression. There was a negative correlation between the two variables. Then you report your actual correlation results, which was the R, 118, which was the degrees of freedom, equals 0.068, which was your actual correlation result, and then P less than 0.01. Okay, and you could add the scatter plot if you did that. It's not necessary. So you can skip that one line that says a scatter plot summarizes the results, because you're not adding that unless you do. And then overall, there was a moderate negative correlation between income and level of depression. Increases in level of depression were correlated with decreases in income. So not only report the actual correlation result, but what does that mean, right? So R118 equals negative 0.068, P less than 0.01. Yes, that's important, but you can't just end there, because what does that mean, right? That means that overall, there was a moderate negative correlation between income and level of depression, and increases in level of depression was correlated with decreases in income. And that's how you would report your correlation results. Here are just some helpful links to help you as you're writing up your final paper for this class. It can show you, like for example, the first one shows like what test you should use depending on your level of measurement for each variable. It also has to help you with sample size, determining what sample size you need, and also effect size and how to report your results. So these can help you throughout this assignment, but it can also help you for your actual final paper for this class.